Assalamu alaikum. I'm Hamza from Mechatronics Department of Air University. So today we are going to discuss microcontroller and embedded systems lab. This is lab number 6. In this lab we discuss timers and counters. So this is the introduction to timers. There are basically three timers in Arduino ATMEGA 328P. These are timer 0, timer 1 and timer 2. So timers are the heart of automation. Timers give extra control by giving us not only control over what happens, but when it happens. And then we have interrupts. Interrupts basically interrupt the running program and runs a special interrupt service routine ISR. When ISR has been finished, the running program is then continued to the next instruction. Then we have every timer needs some clock source. This is the formula for prescaler. Then we have modes. We have four modes: normal mode, CTC mode, fast PWM, and phase correct PWM mode. So this is all about the theory of timers and counters. We have to just consider the tasks, their code, Proteus, and hardware. These are like the examples. Let's consider the example. So we have to write a program to toggle all the bits of port B continuously with some delay. Timer 0 and normal mode without any prescaler. First we define the CPU speed, then we add the header file, then we make a delay function in the int made. We declare port B as output, then we have while loop for port B, where close 55, then we use the delay function. In the delay function, we make TCNT 0 is equal to 0 cross 20. We load the TCNT, then we make TCCROA. As we are using A register, so we make TCCROA 0 cross 00 for normal mode. Then we have TI. As we are not using any prescaler, then for TCCROB timer 0, we make 0 cross 01 for no prescaler and timer 0. Then we have while for TIFR0 and 1 TOVO equal to 0. So timer 0 wait for here. Then we make TCCROP is equal to 0 and then clear TOVO V0. These are the examples. So now coming to our lab task. Our first task is basically to display TC anti-register on LCD. So coming to its program. So this is the main file. What we are doing first, we declare the CPU speed, then we add the header file uh, of AVR, then we use a display header file, then we make higher bit 0 and higher bit register 0. After that, we use the display count and display read functions. Then we used, so after that we use the characters array in the int main. We declare port B, C, and A. Port C and A are the output ports. Then we display TC and T equal to and store it in string 1. In string 2, we display count is equal to, and both strings are to be displayed on the LCD. So we store them in LCD string. After that, for while loop TCCRO is equal to 0 cross 0 0, as for example, we see this for normal mode. Then we make TCCROP is equal to 0 cross 0 5. So if TIFRO and 0 cross 0 1 equal to 0, then we increment in A and store this A in port A. Then we have count plus plus. This is basically to count the TC and T register values. Then we have cursor line, cursor right, and cursor left functions. And this function which stores the data. So then we have cursor line, cursor right in void, cursor right in void display reg function. So this stores and displays, basically displays the values of the register. If data less than equal to 0 cross 0 f, then what will happen? Cursor left 0 cross 0 1, and the data to be int 2 char will be stored in disk and displayed on the LCD. Else, what will happen if cursor left 0 cross 0 2, then check becomes data and check h is equal to check. Check is basically this data and 0 cross f0. So after that we have h bit in which register is being incremented. Then what will happen? H bit reg is going to be stored at H bit, and then we display this H bit at LCD data. So this is going to be displayed at LCD, and then this function is going to be end and it will return to the original value. So let's come to its Proteus. This is the Proteus for our previous task, lab task. Now we open the Proteus for this task one, in which we monitor and basically displayed the value of TCNT register. So this is LCD. We connected the data bins to IO37 to basically IO30 to IO37. This is port C, and RS, RW, and E to port B. Again, VSS is connected to ground and VDD connected to our power supply. Now let's upload this hex file. So we uploaded the hex file. Yes. So we have uploaded this hex file. Now check. So first TCNT equal to displayed on the LCD, then count equal to displayed on the LCD, then TCNT value 0 and count becomes 1. As TCNT value changes very fast, so for 19 it becomes count 2, then 26 for count 3, and 33 for count 4, and so on. So we have displayed TCNT values on the LCD, and then it becomes in hex. So this is our task 1, to display TCNT values on LCD. Now coming to next task, our next task is basically to make a digital watch using timers. So our next task is to make a digital watch using timers. Let's come to this task. This is task 2. So this is task 2. We have performed this task in group. So in this task, we have to make a digital watch using timers. First, we define the CPU speed, then we add the header file of AVR, header file library of LCD, display function, int2, char array in which we display these numbers. As we have to make a digital watch, so we have to display hours, higher and lower bit, minutes, higher and lower bit, and seconds, higher and lower bits. So we made functions for display hours h for higher bit of hours, for display hours l for lower bits of hours, and in the same manner we make uh, hours, minutes, and seconds higher and lower bit functions, and then we have a delay function. In main, what we have done is we make port B and port C as the output ports. This is LCD initialize function in which we have a higher bit and lower bit for seconds, minutes, and hours. So we have initialized these bits. So for higher bit of hours equal to 0, higher bit less than equal to 2, and higher bit hours plus plus. If higher bit for hours 0, uh, so it runs for 2 for higher and lower bits, and then it increments the higher bit for the hours. This is the outer loop. In the inner loop we have display hours h function, which displays the higher bit for hours, and then we have a for loop, which is the inner loop. Like in this loop we have lower bit for hours equal to 0, it runs for less than equal to 3, and then it increments the inner loop. Then we have display hours L lower bits, and for if higher bits for minute equal to 0, higher bit for minutes less than equal to 5, and then it increments this, and then we have higher bit for minutes function for lower bit, which runs for less than equal to 9 for 10 times, and then it increments this. In the same way we have seconds, higher bit and lower bit functions display seconds, and we have time delay function. So if we make a time one delay function, TCNT1H restores the higher and TCNT1L restores the lower bit. TCCR1A, TCCR1B. This loop, if hours greater than 0, cursor left becomes 8. We have if and else conditions here, and then we have hours, which then stores into char hours h in it, and then hours to be displayed on the LCD data. Then we have hours that stores into char hours dash one function. So if it is greater than 0, then cursor left to 7 and cursor right to 1. Else LCD is displayed hours and colon. In the same way, we have this minutes function. So void display minutes unsigned char min1 stores min1 into char that is stored in min. If min1 greater than 0, so cursor moves left to 4 and cursor right to 1. Else again min and colon. In the same way, we have this seconds, and by display seconds, the second greater than 0, cursor left 1, and then this int to char sec1 is stored in sec, and then this second is stored to LCD data. So we have to make a digital watch using timers. Now come to its Proteus. So we open its Proteus file. Let's come to its Proteus file. Semester 5. Left us tasks. Proteus task 2. We open this. Again, we have the same connections as in the previous task. So from D0 to D7, we have used port C and port B for RSRW and enable. VSS to ground and VDD to power. Now let's upload the hex file. So we upload it. We have to upload hex file of this task. Debug hex file. We have uploaded the hex file. Okay. Now let's run this code. So this is digital watch using timers, and we have seen that this is for hours, this is for minutes, and this is for seconds, and it is running very accurately. So this is all about task number 2. So we have done 2 tasks in this lab. There are basically 3 tasks. The task 3 is to make a counter using pull up configuration. So we have to make a counter, and this that counter display the value on the 7 segment display, and we have a pull up configuration. Now let's come to first code of this task. So this is the code for this task. First we define the CPU speed, then we add the header file for AVR, then we have a display function for characters, display num16 array in which we store the values in hex form. In int when we display port C as output port, and we are controlling the 7-bit of port D, TCCROA0, TCCROB, and TCND0. So port C display TCND0, and we store this display num in red and then return this red to 7 segment display. So let's come to the Proteus of this program. So Proteus for this is given below. We have used a 7 segment which is connected to port C, and then we have this pull up configuration. Let's upload this hex file for better understanding. Documents, micro lab task. So we have task 3. Here we have the hex file. So we uploaded the hex file. Now come to its. So in pull up configuration, as we does not press the push button, so 7 segment displays as 0. When we press this push button, so when we press for 1 time, it becomes 1. For second time, we press it and pull it, so it becomes 2. Then it becomes 3. Then it becomes 4, and so on. So there are 3 tasks in this lab number 6, and I have explained all these tasks. For any query, you can comment below. This is all about lab number 6. Thank you. Allah Hafiz.